So I have some thermometers here on the wall. The one on the left is known as a Galileo thermometer, and it operates on the principle that as the temperature goes up, the density of a liquid decreases. So as the temperature of the liquid here increases, the balls that are floating are not buoyed up as much as they were at a lower temperature, so they begin to sink. Each of the spheres has a brass weight attached to it, and those brass weights and the weight of the spheres have been carefully calibrated so that they will sink at the appropriate temperature. So the lowest floating sphere here reads 70 degrees, the highest sunken one reads 68 degrees. So if this is accurate, which it is, then the temperature in the room is somewhere between 68 and 70. If the temperature goes up, these start to sink, and eventually it will top out about 80 degrees when everything is sunk. This is a second thermometer, as you can see from the label. It has similarities and differences to the Galileo thermometer. They both have a sphere, but in the second thermometer, the one on the right, the sphere stops halfway down. It's relatively easy to get a sphere to float or to sink. It's much harder to get it to stop halfway down in the liquid. The way this one works is that coming down from that glass sphere is a glass rod that ends about here. And there is actually a second liquid, a much denser liquid, at the bottom of the apparatus. The interface between the two liquids is here. So when that glass rod goes into the lower liquid, the buoyancy of the lower liquid, because the lower liquid is much denser, buoys it back up. If this were to go too high, you wouldn't have the buoyancy of the lower liquid there. And so they've got it adjusted so that it reads the right temperature. We will see this principle operating again when we get to the mobile globe, but we'll leave it at this for the moment. This is another example of a Galileo thermometer. The main difference is that most Galileo thermometers have a colored liquid inside the spheres, and that usually gets bleached out or turned black by the sunlight over the course of years. This works the same way based on buoyancy and density changes, but here the spheres are made out of stained glass, and so the color doesn't change. Other than that, it works the same way. This one functions on a similar principle. The ball is floating not at the top and not at the bottom, somewhere in the middle. It's carefully adjusted so that the temperature reads 70 degrees, which is what the temperature in the room is. The mathematics that allow one to understand what's going on here are a little more complicated because this chain, this metal chain, its weights vary not in a unitary way, but more, let me just say that again. The effect of the weights are more complicated because the chain is attached to the back of the apparatus, so it's more of a continuum of weight changes rather than incremental ones like one sees in each sphere floating or sinking in a Galileo thermometer.